So go
Accuracy
over
and
page
precision,
exam
1 through
review.
7
The difference
first
between
semester.
exam review
A and B,
the first
difference
one
between
is
scale A and B
accuracy
and
and
precision.
precision.
Scale B has
Accuracy
points
is how close
or
the
number
closest
values
that are
that are
closer
closer
together and
number
cluster.
value or the center of a
So that
target.
makes them precise.
Well, the actual number value
But they're
in the
not
sentence
as
at the top
accurate as
says
they need to be.
The mass was measured.
Since the actual
and
mass
its known
in the
mass
sentence at the
was
top
32 grams.
says to measure the
So
mass
when we
of
look
an
at
object
scale A
is
and
known
scale
to have a
B
mass
and the
of
3 different
32
trials on
grams,
each one, none of those
none
were
of the
close
values
to
are close
32
to that.
grams.
So for
So
question
none of those
C,
measurements were
the scales
accurate.
accurate?
For
No,
letter C, the
they were
scales were not accurate.
And then just to get an average, you add up
question
all your
A,
trial numbers
which scale
and divide by
measured
3
the
to get your
object's
average
most
value on letter
precise?
B.
Means which
Question
one
two,
has a cluster of numbers
identify
closest
solids,
together.
liquids, and gases.
So
So
scale
going back
B
to your
has
slides
numbers that
and
are
your
closest
PowerPoint
together.
review, you should look
The
back at
27,
27 if you're
29,
not sure how to
28.2.
identify solids, liquids, and gases by these
And then to get an average of
descriptions,
those,
you should know
add the 3 of those up, divide by
Question
3,
three,
you get 28.1.
Which
is the
term best
average.
describes the process by which liquids transform
Question 2,
to a
identifying the
solid by the
shape
removal of heat
that's going to be freezing something and crystallizing
of a
it back.
container
So
when
freezing
something
or
flows
crystallization.
in it? That would be a gas. Which term best describes the
particles
process by which
held in a
particles
specific arrangement
escape
is
from a
solid.
non-boiling liquid to a gas?
Gases are
If it was
compressible.
boiling, it would be evaporation.
Liquids and solids both
And
have a definite
If
volume.
it's not boiling, it can also be evaporation.
So
So
gases will
transpiration
occupy
and
the entire
evaporation
space of a
are the
container.
same term when we talk about
Definite volume but flows
evaporation.
is a liquid.
3 is A for crystallization, 4 is A, evaporation. 5, the subatomic particles, there's 3 of them. Subatomic particles include electrons, protons, and neutrons. It is the protons that identify an element, and that is the atomic number also. So the atomic number tells you the number of protons existing. Question 6, if you go back and you number all the tall columns 1 through 18, then these are the charges you'd have based on group 1 has 1 valence electron to give up 1 electron, so it's positive 1. Group 13 would be where boron sits, and so it's positive 3 charge to give up 3 valence electrons as the third tall valence column. Group 15 is where nitrogen's column is. So nitrogen has 5 valence electrons as the 5th tall column, so it needs to gain 3 more electrons. That's why it has a negative 3 charge. Group 17 is the halogens, where fluorine is at. So they have to gain 1 more electron to reach 8 valence electrons. So group 17 charge is a negative 1. The atomic radius changes as you go across a period, which is horizontally across one particular row, has the same number of orbital rings around the nucleus, but you're adding 1 more proton in the nucleus as a positive particle, along with adding another negative particle in that outermost orbital. And that attraction between the positive and negative keeps increasing. Well, it's like 2 magnets. As you get stronger magnets, they start pulling closer together. So the elements, as you move to the right across a horizontal period, the element size becomes smaller, or the atomic radius becomes smaller. Then the size, to answer question 8, drives the ionization energy. The smaller the size of the atom is, the further you go to the right on a row, then the stronger the ionization energy is and the electronegativity values are. So if you're comparing a larger atom to a smaller atom and you need to know which one has a greater ionization or electronegativity, it's always the smaller atom size has the greatest ionization or electronegativity values.